Now that I hope you're getting familiar with these equilibrium laws as they apply to chemical reactions, and you're able to write them and do some limited calculations with them, you might start noticing that these are very mathematical, which means you're going to be doing some pretty complicated calculations in the near future, but not today. Now, when you do calculations, that is quantitative. You're dealing with numbers, quantities, you're calculating answers, you're measuring answers. Today, we're going to look at qualitative interpretations of things. Qualitative means you describe it in words, no calculations required, which most students kind of prefer. However, qualitative can be kind of tricky and you have to be familiar with it. So we're going to look at how to look at an equilibrium reaction with a really large KEQ. So let's get started with my favorite equilibrium reaction. You probably know what's coming. Okay. And let's keep it as simple as possible. 1, 1, 1, 1. All right. The equilibrium law, which gives us KEQ, is my products in quotes, really the right-hand side, divided by the reactants in quotes to the left-hand side. Okay, so far so good. Now, suppose all we know about this is the number for KEQ. Now, let's assume that KEQ is really big. Now, how big is really big? Well, hopefully you're familiar with this in math, right? If KEQ is greater than, let's show you something a little fancier. If I put two of them side by side, that means much greater than. And this is where it gets a little flaky. 10 to the 5, which is large. So if KEQ is a number bigger than 10 to the 5, in fact, much bigger, and these get to be huge numbers, then I can make some assumptions about this ratio. So KEQ is really big, right? That must mean we have a very large number on top divided by a very small number on the bottom. That's how you get big numbers from a ratio, right? Simple concept in math. So at equilibrium, almost all of the A and B have reacted. In fact, there's almost none left over. So big deal. Well, it is a big deal because my life just got really simple. So I can take my chemical reaction and it's going to have the same two reactants, the same two products. You notice I skipped over the middle. So instead of writing a two-way arrow, I can just put a one-way arrow. That really simplifies my calculations. Essentially, all of the A and B react to form C and D. Okay, I know a little bit doesn't, and some of the C and D goes backwards, but you'd never notice, especially when you're dealing with measurements and errors and significant digits. So you can forget equilibrium if really things have really large KEQ values. In fact, all chemical reactions are equilibrium reactions, but the bulk of them have huge KEQs, and we don't care. You'd never notice the little bit that doesn't react or gets remade. So remember all that stuff in Chem 20 when you were looking with stoichiometry and chemical reactions? Well, congratulations, you were dealing with equilibrium. Your next mini lesson will look at small KEQ values.